Our world is mathematics because it is all around us. Everything is mathematics. Mathematics is everything. Everything is made easier because of mathematics. Whether in cooking, singing, painting, citing information, and in technology. We all know that we are in generation of hand-on technology that provides methods in organizing and structuring knowledge. Within the technology, the number theory evolved. Hi, I'm Chesa Capascia discussing about Lesson 3, Number Theory. The title of this video is The Number Theory Towards Technology, since the number theory works more in technology, with the theme identifying the importance of numbers by applying in real-life situations. Number theory, the branch of mathematics which helps to study the set of positive whole numbers. Number theory helps to study the relationships between different sort of numbers. Natural numbers are separated into a variety of times. Even numbers, the numbers that are evenly divided by 2 are called even numbers. Odd numbers, the numbers that are not evenly divided by 2 are called odd numbers. Square numbers, a number multiplied by itself, is called square numbers. Cube numbers, a number multiplied by itself 3 times, is called cube numbers. Prime numbers, if a number has only 2 factors, 1 and the number, is called prime numbers. Coprime numbers, 2 numbers are called coprime numbers if the highest common factor between the 2 is 1. Composite numbers has more than 2 factors. The composite numbers are the prime numbers. The number 1 is neither prime nor composite. Modulo 4, numbers that said to be one number if it leaves a remainder 1 when divided by 4. Similarly, if a number leaves a remainder 3 when divided by 4, it is said to be 3 number. Next is triangular numbers. A number is said to be a triangular number when that number of pebbles that can be arranged in a triangle using 1 pebble at the top, 2 pebbles is next row, 3 pebbles in next row, and so on. Fibonacci numbers are created starting with 1 and 1, then get the next number in the list and adds the previous 2 numbers. Say 1 plus 1 equals 2, and then add 1 plus 2, you get 3, then adds 2 plus 3 gives 5, then 3 plus 5 gives 8, and so on. And now let us proceed in problems and solution. Find the greatest common divisor or GCD of a number 30 and 52. So the divisors of 30 are 1, 2, 3, 5, 6, 10, 15, 20. And the divisors of 52 are 1, 2, 4, 13, 26, and 52. So the common divisors in 30 and 52 is 2. Therefore, the GCD of 30 and 52 is 2. So next is find the common factors of 10 and 16. So the factors of 10 are 2 times 5 equals 10 and 1 times 10 equals 10. Therefore, the factors are 1, 2, 5, and 10. And the factors of 16 are 4 times 4 equals 16, 1 times 16 equals 16, 2 times 8 equals 16. Therefore, the factors of 16 are as follows: 1, 2, 4, 8, 16. Then, the common factors are 1 and 2. Show that the greatest factor of a number is the number itself. Assume that 24, that is not number 21, that is 24. So, the factors of 24 are 1 times 24 equals 24, 12 times 2 equals 24, 8 times 3 equals 24, 6 times 4 equals 24. So, the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. From this, we can say that 24 is the greatest factor of a number 24. Prime and composite numbers are the two types of numbers that differ based on the number of factors they have. A prime number is the one that has only two factors, and a composite number has more than two factors. A factor is a value that can divide a number or an expression evenly. Prime numbers is the one has exactly two factors, which means it can be divided by only one and itself, but one is not the prime number. Example of prime number: 3 is a prime number because 3 can be divided by only two numbers. For example, 3 divide 1 equals 3. 3 divide 3 equals 1. Composite has more than two factors, which means apart from getting divided with the number 1 and itself, it can also be divided by at least one integer or number. Example of composite number: 12 is a composite number because it can be divided by 1, 2, 3, 4, 6, and 12. For example, 12 divide 1 equals 12, 12 divide 2 equals 6. 12 divide 3 equals 4, 12 divide 4 equals 3, and 12 divide 6 equals 2, and 12 divide 12 equals 1. Types of composite numbers. First is even composite numbers. Even numbers are not prime numbers. That is called even composite numbers. For example, 4, 10, 16, 28, 56, etc. Next is odd composite numbers. The odd positive integers or the odd numbers that are not prime numbers are called odd composite numbers. For example, 9, 21, 33, 45, and etc. Let's proceed to the prime factorization of natural numbers. Prime factorization is a process of finding the prime numbers which are multiplied together to get the original number. It is defined as a way of finding the prime factors of a number such that the original number is evenly divisible by these patterns. These are examples of prime factorization. The prime factorization of 12 is 2 times 2 times 3 equals 2 to the power of 2 times 3, and 18 is 2 times 3 times 3 equals 2 times 3 to the power of 2. And the factorization of 24 is 2 times 2 times 2 times 3 equals 3 to the power of 3 times 3. And the prime factorization of 20 is 2 times 2 times 5 equals 2 to the power of 2 times 5. And the 36 is 2 times 2 times 3 times 3 equals 2 to the power of 2 times 3 to the power of 2. There are methods of prime factorization. First is division method. The steps to calculate the prime factors of a number is similar to the process of finding the factors of a large number. Example of division method for prime factorization. Step 1 is divide 460 by the least prime number. So 460 divided by 2 equals 230. Step 2 is again divide 230 with the least prime number. Now 160 divided by 2 equals 115. Step 3, divide again with the least prime number, which will be 5. So 155 divided by 5 is 23. And step 4, 23 is a prime number. Divide it with itself to get 1. Now, the prime factors of 460 will be 2 to the power of 2 times 5 times 23. Second is the factor 3 method. In factor 3, the factors of a number are found and then those numbers are further factorized until we reach the the closure. In this figure, we can have number 60 is first factorized into two numbers, 6 and 10. Again, 6 and 10 is factorized to get the prime factors of 6 and 10 such that 6 equals 2 times 3 and 10 is equal to 2 times 5. If we write the prime factors of 60 all together, then prime factorization of 60 equals 6 times 10 equals 2 times 3 times 2 times 5. Same is the case for number 282, such as 282 equals 2 times 141 equals 2 times 3 times 47. So in both cases, a tree structure is formed. And the fourth topic is the greatest common factor. The greatest common factor is commonly known as GCF. It is also known as highest common factor or HCD, highest common factor or HCF, and greatest common divisor or GCD. The greatest common divisor of two or more numbers is the greatest common factor number that divides them, exactly factor that is the highest among the numbers. For example, 15 divided 5 equals 3 and 10 divided 5 equals 3. There are several methods to find the greatest common divisor of given two numbers. First is prime factorization method. Each given number is written as the product of the smallest power of each common prime factor. This method is applicable only for positive numbers or the natural numbers. For example, find the greatest common factor of 24, 30, and 36. The prime factors of 24 is 2 to the power of 2 times 3, and the prime factors of 30 equals 2 times 3 times 5, and the prime factors of 36 is 2 to the power of 2 times 3 to the power of 2. From the factorization, we can see only 2 times 3 are common prime factors. Therefore, GCD is 24, 30, 36 is equal to 2 times 3 equals 6. Second is long division method. In this method, the largest number among all given set of numbers should be divided by the second largest number, and again, the second largest number should be divided by the remainder of the previous operation. This process will continue until the remainder is 0. The third method is Euclid's division algorithm. This method is stated only for positive integers. This is the GCD formula. If A and B are any number, then the greatest common divisor of A and B can be given by below. The last topic is the least common multiple. The least common multiple is a value that is evenly divisible by the two given numbers. LCD is also used to add or subtract any two factors when the denominators of the fractions are different. It is also a method to find the smallest common multiple between any two or more numbers. This is the LCM formula. Let A and B two given integers. The formula to find the LCM of A and B is given below. Also, the formula for fractions, LCM is equal LCM of numerator divided by HCF or the highest common factor of denominator. Also, LCM, there is different methods. This is important methods by which we can find the LCM of two or more numbers. First is the listing. The least common multiple of any given numbers is first to list down the multiples of specific numbers and then find the first common multiple between them.
For example, suppose there are two numbers 11 and 33, then by listing the multiples of 11 and 33, we get multiples of 11 is equal 11, 22, 33, 44, 55, and so on. So the multiple of 33 is equal 33, 66, 99, and so on. We can see the first common multiple or the least common multiple of both the numbers is 33. Hence, the LCM is 1133 equals 33. Another method to find the LCM of the given numbers is prime factorization. Example, suppose there are three numbers 12, 16, and 24. Let us write the prime factors of all three numbers individually. The factors of 12 equals 2 times 2 times 3, and 16 equals 2 times 2 times 2 times 2, and the 24 equals 2 times 2 times 2 times 2 times 3. So, writing the prime factors of all three numbers together, we get 12 times 16 times 24 is equal 2 times 2 times 3 times 2 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 times 3. So, now pairing the common prime factors, we get the LCM. There are 4, 2, and 1, 3. So the LCM of 12, 16, and 24 will be LCM 12, 16, 24 equals 2 times 2 times 2 times 2 times 3 is equals 48.
Is division method. Finding LCM of two numbers by division method is an easy method. This is the steps of division method to find the LCM. First is write the numbers separated by the commas. Now divide the numbers by the smallest prime number. If any number is not divisible, then write down the number and proceed. Further, keep on dividing the row of numbers by prime numbers unless we get the results as 1 and a complete row. Now, LCM of the numbers will be equal to the product of all prime numbers we obtained in the division method.
Let us understand with the help of examples. Find the LCM of 10, 18, and 20 by division method. So this is the table to divide the numbers by prime factors. Therefore, LCM 10, 18, 20 equals 2 times 2 times 3 times 3 times 5 equals 180. Now, if we have to find the common multiple of two or more numbers, that we have to write all the multiples for the given numbers. We constantly use and rely on prime numbers for cyber age security. Prime's odd mathematical property is used in encryption and decryption. They are used in generating error-correcting codes used in telecommunication. Mathematics also applied in cryptography, device authentication, websites for e-commerce, coding, security systems, and many more. Technology provides additional opportunities for learners to see and interact with mathematical concepts.